Hi, I'm Lei Jinzhi. Today I'm going to talk about some interesting knowledge in calculus. Follow me. First, I will introduce the application of derivatives to economics. Assume that you open a pen factory and you make Q pens a day. So there must be a cost for making Q pens, and the function to show how much you cost to make pens is the cost function. And assume that the cost function is CQ equals 1000 plus 4Q plus 0.01 times Q power 2. And when you make 100 pens, you have to spend 1500 written below. Then what is the meaning of derivative of cost function? It is the marginal cost. It shows the cost when you have already made a Q pens. What's the cost to make one more? So under the cost is of making the 101st and 201st pen, we can see that the cost of making one pen is rising as making more pens. Then the average cost function it's written as CQ divided Q, meaning the cost of each pen when you make Q pens. And you can see when you make 100 pens, it costs 15 per pen. And the derivative of the average cost function is to find the least cost of making one pen. So when the derivative equals 0, which means making around 316 pens, the average cost of making a pen is the lowest. Next is the revenue function, which is RQ equals P times Q, where P is how much you sell a pen here. We assume the price of pen is PQ equals 20 minus 0.1 Q when sell a pen. And the revenue function is 20Q minus 0.1 Q power 2. And the derivative of the revenue function is the marginal revenue, which is 20 minus 0.2 Q here. And when Q equals 0.50, the revenue for selling the 51st pen is 10. And the average revenue function is the P we talked of before. So from its derivative, we can see that when we sell more pens, the revenue of a single pen is decreasing by 0.1. Next is the profit function, which means revenue minus cost, and here is 16Q minus 0.11Q power 2 minus 1000. So through finding its derivative, we can tell when the profit raises and the highest to the highest. So when the derivative reaches 0 here, which is Q equals 75, means you can make the most profit by making 75 pens. So the average profit here is the profit of every pen you will make by making Q pens. And what's the meaning of the derivative of this function? It helps you find how many pens you should make to maximize your profit. And when it equals 0, which is making 95 pens, maximizes your profit. Now this is the end of 6 functions and the applications of their derivatives. Now I will explain how to use washer method to calculate the volume of a solid. First, when the graph rotates about the axis, it will form a concentric circles, which is a circle containing another circle. And we divide the solid into infinite calendar with the circle as bottom and dx as height. We assume it's about x-axis, then we can see the volume of the solid as the sum of the volume of all the calendars, and each calendar's volume is the bottom times height. The bottom is pi r out power 2 minus r in power 2. You can see that r out is the furthest distance from the curve to the x-axis, and r is the nearest. The volume of a calendar is pi r out power 2 minus r in power 2 times dx, and you can see the function down, which is integrating all the volumes. When you rotate about the y-axis, you only need to turn x into y, and the other steps are the same. Now let's see a real example, and you will know how to do it. This is two curve y equals x and y equals x times e power 1 minus x divided by 2. And the rotate is about y equals 3. So it's about y equals 3, which is parallel to the y-axis. So we will use the second method. Here is the process of the example. It's easy to understand, but during the calculation, we need to apply the integration by part, especially the first one needs to do this 2 times. You can stop to have a look and understand. Next, we will talk about the moment and the center of mass. The moment can be understood as how much power can a point cause in the system, which is mass equals F times dy, which can simplify to my times dy. And the center of mass can be seen as a point where all the moment can balance. We assume this point is x bar, and we can calculate it by writing a balance formula and simplify it to the formula m1 times x2 plus m2 plus times x2 divide m1 plus m2. And when we have many x in both sides, we can do the same thing and the result is similar, which is the sum of all moment dividing sum of all m. But what if not all the mass are in the same line? It is almost the same. The only thing you have to do is to split the moment into 2 parts, one x-axis and one y-axis. Then you can do the same thing and get 2 results. And the point combining this result is the center of mass. So when it comes to graph, the total mass is the area of the graph times rho. You should imagine that there are infinite points and every point have its own mass, and split it to 2 parts and do the same thing we talked above, so we can get the moment. Here is some graph to help to understand. You can stop to look. Finally, when you divide the moment of 2 parts by the mass of the graph, you can get a center of mass of a graph. Here is an example to help you understand. The first step, you need to calculate the mass, which is A, and you get 1 over 3, and through the formula I gave above, and you can get x bar and y bar, and the combination of it is the center of mass you can stop to see. That is all. Thank you for listening.